Alright, welcome back. We'll continue from where we stopped in our last class, where we just introduced ourselves to differential equations. So for this video, we'll talk about the order and the degree of a differential equation, and we'll move over to linear and non-linear differential equation. Now, when you're analyzing the order of a differential equation, you have to work with the differential coefficient. But once you are analyzing the degree of a differential equation, you will work with the power of that differential coefficient. So if you have dy over dx as probably the differential coefficient, or the square y over dx squared, this is what you work with to get the order. But the power of this differential coefficient is what you work with to get the degree of that equation. So the order of a differential equation is actually the highest derivative of that differential equation. Let's say you have y equals to 3x squared, 3x cubed plus 3y. This is not plus 3x squared. This is not a differential equation, but let's obtain a differential equation, a possible differential equation. Dy over dx is equals to 9x squared plus 6x. Now, if we leave it like this, the order of this differential equation is order 1, because the power here is just the first derivative. It's just the first derivative. If I differentiate the second time, and I have something like this, 18x plus 6. This, because I have the second derivative here as the highest power, even if I have another dy over dx here, even if I have something like this here, but the highest derivative here is the second derivative, that becomes the order of this differential equation. So if you have something like d cube y over d cube x plus d square y over dx squared plus probably dy over dx equals to 3. The highest derivative here is 3. So the order of this differential equation becomes 3. But when you talk about degree, it is the power of the highest derivative. The power of the highest derivative. So if we have dy over dx all square plus d square y over dx square all raised to power 3 plus d cube y over ds cube equals 1. Now, first of all, the order of this differential equation is 3 because the highest derivative here is the third derivative. So the order is 3. But the highest power in this equation here is 3. But that does not mean that the degree of this equation is 3. The degree is the power of the highest derivative. And the power of this highest derivative is 1. So the order of this is 3. And the degree is 1. But you must note that some differential equations has fractional powers. So to obtain the degree of those differential equations, you make sure you clear all fractional powers. Once you are done clearing all the fractional powers, you can obtain the degree of that differential equation. Let me drop an example. Suppose you have something like dy over dx plus d square y over dx square, everything raised to power 1 over 3. There's a fractional power here, and it equals to the, let me say, the cube y over dx cube. Now, I must first of all clear this fractional power first from this differential part, so that everything will be integer powers. Now, once I clear that, I will have dy over dx plus d square y over dx square equals to, if I cube both sides, I will have this cube y over ds cube raised to power 3. Now, because I have cleared all fractional power, I can therefore say that the order of this differential equation is 2, and the degree is, the order is 3 and the degree is 3. That's all for order and degree. Don't forget, the first thing you must do is to clear fractional power first, if there is any fractional power. So let's talk about linear and non-linear differential equation. Now, for a differential equation to be linear, it must be in this form: a function of x times the differential coefficient. I'm giving an example: plus a function of x times the differential coefficient plus a function of x times the differential coefficient plus probably a function of x times y equals to maybe another function of x. So if this differential equation, the order of this differential equation is order 3, but what is multiplying this is f of x, a function of x only, and not a function of y. Because it is only a function of x that is multiplying this differential coefficient and y, we say this is a linear differential equation. Now, supposing we have xy, the square y, over the square x. There is a function of x and y multiplying this differential coefficient. So no matter anything I have here, it is not a linear differential equation. It becomes non-linear differential equation. So anytime we have a function of x and y multiplying, if we have y square here, it is still not a differential coefficient. It is still not a linear differential equation, because this is not y, this is y square. Y is multiplying y to get y square. So because there is a product of xy, a function of x and y multiplying this, it is not a linear differential equation. It is a non-linear differential equation. So anytime a function of x only is multiplying all the differential coefficients and a function of x only is multiplying the dependent variable, we tend to call them a linear differential equation. So let me drop 3 examples. dy over dx plus xy square equals to 3x dy over dx plus y equals to 4, y dy over dx plus xy equals to 5. And a good example to explain this is this. Now, what is multiplying dy dx here is 1, which is a function of x raised to power 0. But what is multiplying y here is xy, because xy times y is xy squared. And from here, we said it must be only y. So this is not a linear differential equation because there's y squared here. This is what spoiled it. Now, for this second one, what is multiplying the differential coefficient here is a function of x, 3x, which is okay. And what is multiplying the y here is 1, which is not a function of y, but a function of x. So this is also a linear differential equation. Here, what is multiplying y is a function of x. But what is multiplying this differential coefficient is a function of y. So this part is what made this not to become a linear differential equation. So this is a non-linear differential equation. So that will be all for this video. In our next video, we'll be talking about how to obtain a differential coefficient, how to obtain a differential equation, given the solutions to that differential equation. And we'll talk about general solutions, particular solutions, and singular solutions of a differential equation. So that'll be all for this video. Please do not forget, like and subscribe to this channel. I'll see you guys in our next video. Thank you.